All right. So, physics stroke chemistry. Yeah, good afternoon, sir. Okay. Yesterday we did um, three gas laws. We talked about the the concept of Grant's law of diffusion. We talked about Dalton's law of partial pressure. We talked about uh, Charles' law, right? We talked about Grant's law of diffusion, which states that uh, okay, we talked about Grant's law of diffusion, which states that the rate of diffusion is inversely proportional to what? To the square root of what? The rate of diffusion of a gas is inversely proportional to the square root of its what? Of its vapor density. Do you understand? It's inversely proportional to the square root of its vapor density. Do you understand? And we did, I told you that in WAEC, JAMB, or whatever exam you are, they will not give you the vapor density like that, okay? They will have to give you what? The relative molecular mass, right? So just know that the relative molecular mass is twice the vapor density. Are you getting it? Do you understand? So all you just have to do is just from the relative molecular mass, you can get the vapor density, right? By what? By dividing the vapor density by 2. Is it not? Then we talked about the Dalton's law of partial pressure, which states that when there's a mixture of gases which do not react chemically with one another, all right, the total pressure of what will be the sum of what partial pressure of the individual gases, right? And we talked about how we can get the partial pressure from the total pressure, right? That is multiplying the partial pressure, the total pressure by what? By the mole fraction. I also told you that volume fraction is also the same thing as what? As mole fraction. I told you. Some people were asking me, how do we convert volume to moles? Are you getting it? Most of you didn't know when I mentioned that you just use the volume fraction like that. Okay? They give you the volume of each gases. Okay? Each gas, sorry. All right? They give you the volume of this one, give you the volume of this one, give you the volume of this one. All you just have to do is add all the volumes together. When you add all the volumes together, you what? You divide each to get the mole fraction or the volume fraction. Divide what? Each volume by what? By total volume. Am I communicating? And that will give you what? The total. Am I communicating at all? So that is just it. All right? That's just it, basically. That was what we did yesterday. Then we did Charles' law, which we said that Charles' law states that the volume of a given mass of gas or a fixed mass of gas at constant what? Pressure is what? Is directly proportional to what? To its absolute temperature. Now, it's as simple as that. The higher the what? The temperature, the higher the volume, and the lower the temperature, the lower the volume. But the condition for this law is that what? That the volume, the pressure must be what? Must be constant. Okay? So long as the pressure is kept constant, what happens? The temperature will increase when the volume will increase when the temperature increases. Do you understand? That is what we call direct proportionality. All right? The higher the temperature, the higher the volume. Okay? Normally, when substances are heated, what happens? They expand, right? When they are cooled, they contract, unless water, which expands anomalously. Okay? Now, we are going to today's class, which is, we are continuing from there. Okay, I gave you about 6 laws. I taught 3 yesterday. So today we are going to what? The remaining 3. So the next law is what? Boyle's law. Boyle's law. Boyle's law. Now, you see Charles' law, Boyle's law, and pressure law. They relate the 3 different principal properties of what? Of gases. Okay? Okay? 3 important factors that affect gases, and that is what? Temperature, pressure, and what? And volume. Am I communicating? Temperature, pressure, and volume. Okay, in Charles' law, we see that what? Temperature and volume varies, while pressure was constant, right? You will find that in Boyle's law, pressure and what? And volume is varied. while temperature was constant. Am I communicating? While in pressure law, you find out that what? Pressure and volume and what? And not volume and temperature. Pressure and temperature. I guess pressure and temperature was varied. Why was volume was what? Constant. All right. So let's go to Boyle's law. Boyle's law is what? It states that what? The volume of a given mass of gas at constant temperature, the volume of a given mass of gas at constant temperature is directly proportional. It's inversely proportional, It's inversely proportional to what? To its pressure, okay? It's inversely proportional to its pressure. I guess it's provided that the temperature is what is constant. Or you can say the volume of the what? Of a given mass of gas at constant temperature. I guess it's at constant temperature is what? Is inversely proportional to its pressure. Are you getting it? Is inversely proportional to the pressure. That is, when the volume is what? Is varied. When the volume is varied and the temperature is what? Is constant. When the volume is varied and the temperature is constant, okay, the pressure too varies, okay? So how are they dependent on each other? When volume is increased, pressure reduces. When volume decreases, pressure increases. From our normal analysis of pressure, you will know that that's true. You will know that that's true because what is pressure? Pressure is a measure of what? The number of collisions the molecules of a gas makes with the walls of its container, right? Right? How many collisions per second or per minute? Okay, the molecules of what? Of that gas makes with what? With its container. All right, that is what pressure. Okay, when the molecules are colliding more with the walls of its container, when the molecules are colliding more with the walls of what? Of the gaseous container. Do you understand? With the walls of what? Of its container, you'll find out that what? That the pressure is high, right? But when the number of collision is low, that is, it is colliding less frequently. I get it. With the walls of their container, what happens? The gas pressure is what? Is low. In most exams, they will ask you a gas exact pressure on what? On its container. A gas exact pressure on its container because the molecules of the gas are what? Are colliding with the walls of the container. I get it. So when the number of collisions is very, very high, I get it. You find out that what? The pressure will be high, right? But when the number of collisions is very low, what happens? Find out that what? The pressure is what? Is low. Okay? So let's take two scenarios here. The first scenario is in the case where there's a container here. Okay? I put an amount of gas, okay, in this container. Okay? Alright? I put an amount of this gas in this container now, for example. And then I take the same amount of gas, and I put it in a way smaller container. That is volume decrease, right? Alright, the volume has just decreased, is it not? Alright, which one do you think will be colliding more with the walls of the container? The smaller one. If the mass, that's why we call it a fixed mass of gas. If the amount of gas is what? Is fixed, okay? That is, I put a certain amount of gas here. I put the same amount of gas in this place. You will expect that what? The pressure would have increased, right? Because the number of collision with the number of gas molecules was collision with the walls of the container has increased, right? Because of the small compartment. Do you understand? It's increased. So a decrease in volume will lead to what? An increase in pressure. Instead, if I put it in a more larger container here, for example, all right, you will find out that the number of collision with the walls of the container will reduce, right? You see, now that will make the pressure to decrease, right? So this is a verification of what? Of Boyle's law, right? Is it not? All right. But for this to happen, what happens? The temperature must be constant. Because if the temperature changes, remember temperature affects what? Molecular speed. When the temperature increases, what happens? You are giving them heat energy, and they will convert that heat energy to what? To kinetic energy. They will not be moving faster. Am I communicating? So at the very high temperature, a container like this, I guess it can have the same pressure as a container like this. Is it not? when the temperature is high enough, here, the molecules are moving very fast. Here, are you getting it? So if I bring the bring the gas here at a lower temperature, you find out that it might have the same pressure, even with different volume. I don't know if I'm making if I made sense, right? It's a simple thing. If I look at this now, all right, this at the same temperature, definitely the pressure here will be what? Will be higher. Am I communicating? The pressure here will be higher than here. But if I increase the temperature of this one, the molecules of this one will be moving faster, right? Faster. I might increase it to the temperature that what? That the pressure will not be the same. You understand? You understand? So for that law to work, temperature must be the same for both of them. Am I communicating? If the temperature is the same for both of them, definitely a reduced volume will lead to what? To what? To an increased pressure, and a decreased what? An increased volume will lead to what? To a decreased pressure. Am I communicating? That is how it is. It's very, very simple. Very simple. So from there, mathematically, we can understand that V will be inversely proportional to what? To the P. Am I communicating? All right. So from here, we introduce a constant of proportionality, which is what? V equal to what? K over what? P, right? Where K is constant, right? So if K is constant, that means V will be equal to K will be equal to Vp. Are you following? So from here, if K equals to Vp, then we know that what? V1, P1 should definitely be equal to what? V2, V2. So this is the mathematical expression for Boyle's law. Hope you understand. Anybody with question? Please, if you have questions from any textbook or past question, let's do it. On Boyle's law. So, Boyle's law. Before you find any question, as you are finding, let me take one. All right. Okay. Okay, a fixed mass of gas that means P1 is what? 650 millimeter mercury. V1 is what? 30 what? Centimeter cube. We are looking for V2, right? That is P2 is what? 760 millimeter mercury. If the temperature remains constant. This one is what? It's straightforward. Temperature remains constant. You know we are applying what? Boyle's law, right? So from there, we use our what? V1, P1 is equal to what? V2, P2, right? Now what's V1? 30 times P1, 650 is equal to V2, right? Times P2. P2 is what? 760, right? So from here, V2 will now be equal to 30 times 650 over 760, right? So that will give us what? V2 is equal to what? 26 what? Centimeter cube. That's easy enough. Yeah. If they don't give you, they don't tell you, they most likely will tell you. They most likely will tell you that pressure at temperature, they might give you the temperature, they'll tell you at the same temperature. It means it's constant. They tell you if the pressure, if the volume is increased. Maybe they tell you a gas at 30 degrees Celsius having a pressure of 650 millimeter mercury and a volume of 30 centimeter cube. Okay? The pressure was increased to 760 millimeter mercury. Alright? At the same temperature. Okay, at the same temperature, or still at 30 degrees Celsius. Okay. What is the final volume? They will most likely will tell you. All right, most times they'll tell you. Okay. Any question? Yes, another question, please. A gas at what? P peanuts. Is compressed to 1/5 of its volume. Excuse me. That means V2, sorry, is equal to 1/5 of its volume. That is V1/5. Am I communicating? It was compressed to 1/5 of its volume. That means at constant temperature, right? What will be its pressure? We are looking for P2, right? Okay, already we know that P1 is there, but we don't know what will be its what? Volume pressure, right? Okay, that is P1 is P naught, right? We said the gas of pressure P naught, right? That means the initial pressure is what? Is P naught, right? All right. Our final volume is V1/5, right? Yeah, which is V naught, right? So and V1 is what? V naught. So this V2 will now become what? V naught/5. Are you following? So from here, we know that P1, V1 is called what? P2, V2, right? So from here, what do you have? P1 is what? P naught times V1, V naught is equal to what? P2, we are looking for it, right? V naught/5, right? So what do we do? We cross multiply, right? Sorry, so P naught, V naught is equal to what? P2, V naught/5, right? We cross multiply. If we cross multiply, you have what? 5 P naught, V naught is equal to what? P2, V naught, right? Then what do you have? Of course, we are looking for P2, right? We divide both sides by what? V naught, right? V naught. V naught cancel V naught, right? V naught cancel V naught, right? P2 will now be equal to what? Now be equal to what? 5 P naught. Hope you understand. All right, ask your question, please. Why? Exchange what? Just with P1, V1, so P2, V2. Okay. It's still the same thing. It's not peanuts. Do you understand? It's still the same thing. Though in test they use P1, V1. So that one has already used it. Yes, we learn. Is that what you saw in test? Rewrite the law. No. Okay, you asked a question. You said since P1, I said P1, V1 is equal to P2, V2. And V1, P1 is equal to what? V2, P2. If I can state the law as the pressure of a given mass of gas at constant temperature is inversely proportional to its volume. Well, when we say volume is inversely proportional to pressure, it's still the same thing as telling us, saying that what? Technically, that's what it's the same thing as saying pressure is inversely proportional to volume. Am I communicating? All right. Now, yes, any other question? on the book. Yes. Okay. All right. V1 is equal to 20 centimeter cube. At a pressure of P1 is equal to what? Millimeter mercury. Assuming the temperature remains constant, yes? Centimeter or millimeter? Start again. Yes. Yeah. What will be the volume of the gas, right? V2, right? At what? Centimeter mercury. That must be a type error. Supposed to be millimeter mercury. Alright? Supposed to be millimeter mercury. Though if it is centimeter mercury, if you see it in a jam setting, you have to convert centimeter to millimeter. You understand? Not 1,000. It's not 1,000. It's not 1,000. Centimeter to millimeter. We can derive that. Millimeter is what? Milli is times 10 raised to the power minus 3 meter, right? Right? So 1 millimeter is equal to what? 10 raised to the power minus 3 meter, right? Right? Thank you. Now, and 1 centimeter, right, is equal to 10 raised to the power minus 2 meter. So if you have to convert from centimeter to millimeter, you divide by 10. Yes, look at now. This is 1 over 100. 1 over 1,000, right? This is 1 over 100. So if you want to convert from centimeter to meter, I have to divide by. If I want to say this one equal to this, I have to divide by 10. Do you understand? I repeat, this is 1 over 1,000, right? This is 1 over 100. 1 over 1,000, 1 over 100. So you just what? You just divide by 1,000. Divide centimeter by 1,000 by 10. It will give you millimeter. This is 1 over what? 1,000. This is 1 over 100. So if I want to make this equal to this, what would I do? I'll divide this by 10, right? 10 over 1. That is 1 over 100 times 1 over 10, right? That will now be 1 over 1,000. Do you understand? So if you want to convert from centimeter to millimeter, you divide by what? By 10. Do you understand? Do you understand? It's as simple as that. So, but I doubt they will give you something that technical. Are you getting it? So just leave it. It will be millimeter mercury. Are you getting it? So let's go there. All right. So we have P1 V1 is equal to what? P2 V2. P1 is what? 700. V1 20 is equal to what? 750 times what? V2, right? So V2 will be equal to what? 7 times 20 over 750, right? V2 is equal to 14,000 over what? 750, right? V2 will now be what? 18.67 centimeter. So any question? Any questions? So that's just it. That's basically just it. Yeah, just so we'll go into what the next law, which is what? Pressure law, right? Pressure law. Pressure law. Pressure law. Now, pressure law is somehow, if you know, Boyle's law, if you know Charles' law, you know pressure law. Just substitute pressure for volume. Substitute pressure for volume. You know, Charles' law states that what? The volume of a fixed mass of gas or a given mass of gas at constant pressure, right? Is equal to what? So it's absolute temperature. Pressure law will say that what? The pressure of a given mass of gas at constant volume is directly proportional to what? To its what? Absolute temperature. Do you understand? Do you understand? Can you say at a constant volume, the pressure of a given mass of gas at constant volume, they are the same, they are correct. At constant volume is what? Directly proportional to the what? To what? To its absolute what? Temperature. Do you understand? Do you understand? Yeah, simple as that. All right. So from there, you can make your analysis like that. So our it will be what? The pressure, right? The what? Pressure is directly related to what? To the absolute temperature, right? So P will be equal to what? KT, right? Where K is constant, right? That means K will be equal to what? P over T. So K is equal to what? P1 over, so P1 over T1 will be equal to what? P2 over T2. I hope you understand. I hope you understand. Now, this is absolute temperature. Are you getting it? Remember that at all times, T must be in Kelvin. T must be in Kelvin at all times. No, just use absolute temperature. That's the most scientific way to say it. Okay? Do you understand? The way she said it. Temperature in what? In Kelvin. Please, for maximum marks, okay, please use absolute temperature, please. All right, absolute temperature. Okay, so that is just it. All right, so let's see some questions in what? All right. P1 is what? 3 times 10 raised to the power 5. What? Newton per meter square. Now, Newton per meter square is also another unit for what? For pressure. In fact, it's the SI unit for pressure. Newton per meter square. I getting it? And it is dimensionally equal to the Pascal. Pa, PA, is another unit for what? For pressure. Okay? Pa, PA. All right? Yes? C1 is what? 27 degrees Celsius. Yeah? At the end of the journey, P2 4 times 10 raised to the power 5 Newton per meter square, right? C2, right? All right. Of course, the volume will be constant because the tire does not expand, right? The tire remains what? The same, okay? So the volume is what? Constant. So we have what? P1 over T1 is equal to P2 over T2, right? So if you have this, P1 is what? 3 times 10 raised to the power 5 all over T1. Okay, yeah, that's correct. That would be what? 27 plus 273, right? That should give us what? 300 Kelvin, right? So that would be what? P1 is what? 3 times 10 raised to the power 5 over T1. 300, right? Times P2 equal to what? P2. P2 is what? 4 times 10 raised to the power 5 over what? C2, right? So what do? You cross multiply. If I multiply, I have 3 times 10 raised to the power 2 times 10 raised to the power 5, right? Times T2 is equal to what? 300 times 4 times 10 raised to the power 5, right? So 3 times, okay, C2 definitely will be equal to 300 times 4 times 10 raised to the power 5 all over what? 3 times 10 raised to the power 5. So 10 raised to the power 5 will cancel 10 raised to the power 5 here, right? 3 here 1, 3 here 100, right? So T2 will now be equal to what? 400, right? Kelvin, is it not? Which will be what? 400 minus 273. 400 minus 273, that will give us what? 133. 137, right? 137 degree. 127, right? 127 degree Celsius. And that is it. That is, if you see your answer, most of the questions you might be seeing your answers in Kelvin, or you might be seeing your answers in degree Celsius. Are you getting it? All you just have to do, make the conversion, the necessary conversion. Do you understand? Yeah, you add 270 to get what? Kelvin. The value in Kelvin, yeah? If you do it, you will not get the same answer. You'll be wrong. And the funny thing is that the answer that you got will be in the option. So, please, they will solve it the normal way. They will solve it in every stupid way possible. Are you getting it? All right. So, whatever the way you solve it, you might likely see your answer in the option. So that's why you have to what? Solve normally. Okay? Any question, please? Any question, please? Now, yes, more question. Let's just solve one more question, and then we'll move to general gas equation. Yes? So, okay. Let's move to the next thing, which is okay. P1 is what? 2 times 10 raised to the power 5. Newton per meter square. C1 is equal to what? 27 degrees Celsius, right? Which will be what? 27 plus 273, right? Which will give us what? 300 Kelvin. What will be the pressure in it at what? Okay, we are looking for P2. Okay? Alright, T2 is what? 27 degrees Celsius, right? So, what would that be? At 87, right? So that would be what? 87 plus 273, right? That will give us what? 360. Are you there? 360 Kelvin. So we'll follow the formula P1 over T1 is equal to what? P2 over T2, right? P1 is what? 2 times 10 raised to the power 5 over T1, 300 is equal to what? P2 over 360. So from here, we saw in jam like this, if I'm inside Jambo now, it's this kind of thing. All I just have to do is just say 0 cancel 0, 3 here 10, 3 here 12, 2 here 5, 2 here 6. Are you getting it? Right? So I will now cross multiply. If I cross multiply, definitely I'll get 12 times 10 raised to the power 5 is equal to 5 times P2, right? So P2 is equal to what? Right? Divided by 5, right? That will give us what? 2400. Are you getting it? Right? That will be 2.4, right? Times 10 raised to the power 5 Newton per meter square. Okay? Yes. Yes. That's true. Yes. 6 times 2 equals 12. We cross multiply. No. No. Unless T2, they tell you T2 is 0 degrees Celsius. Yeah. That's no use. Alright. Any question? Please, let's go to general gas equation. General gas equation. Now, general gas equation is an equation that is gotten from combining the 3 factors. Now, listen. There are times, it is not every time they will vary 2 factors and leave one constant. Sometimes none of them is constant. Are you getting it? If none of them is constant, you know that what? In Charles' law, we know that K is equal to what? V over T, right? In Boyle's law, we know that K is equal to what? Vp, right? And in pressure law, we know that what? K is equal to what? P over T. If you look at this, you find out that P and V are always in the numerator, right? Yt is always in the denominator, right? So if I combine the 3, it will be K equal to what? PV. Let's say PV. Okay, sorry for changing. PV over what? Over T. Okay? That means it will be equal to what? P1 V1 over T1 is equal to P2 V2 over T2. I hope you understand. Huh? It's not a law, it's an equation. I call it general gas equation of the 3 laws. Are you getting it? Yes. So, do you have a question there? Okay, give me the law. Give me the question. Yes. I've never heard of combined gas law before in my life. Yeah, you said book I read. Please go to that river. Just throw that textbook inside that river. You understand? All right. Read the question to me. At STP. Now listen, when they say STP means what? Standard temperature and pressure. The standard temperature is 273 Kelvin. The standard temperature is 273 Kelvin. The standard pressure is 760 millimeter mercury. So when they tell you at STP, you already know that what? Your V1, your P1 is what? Is 760 millimeter mercury, and your T1 is what? 273 Kelvin. Am I communicating? You understand? You understand? At standard temperature and pressure, at STP. STP means standard temperature and pressure, right? Standard temperature is what? 273 Kelvin. Standard pressure is what? 760 millimeter mercury. So they're trying to tell you that at 273 Kelvin and a pressure of 760 millimeter mercury, that is what they're trying to tell you there. Do you understand? Do you understand? Yeah? Yes, something like that. Yeah. Yeah, you're expecting them to give you the initial volume. Then they'll not ask you a question. Final volume, maybe final volume, final temperature, final pressure. Are you getting it? Yes, continue. V1 is what? 790 centimeter cube. Now, you see that did they give anything like temperature, initial temperature and pressure? They won't. Are you getting it? Because they've already told you at STP already. Okay, so if we do that, if we analyze that, we'll be having what? T1 will now be equal to what? 273 Kelvin. P1 will be 760 millimeter mercury. Are you following? Yeah. Find the what? The temperature. We are looking for T2, right? At which what? V2 is equal to 1000 what? Centimeter cube. Now, okay, yes. P2 is what? Millimeter mercury. Are you following? Do you understand? So from here, we just apply our what? Our law. That is P1 V1 over T1 is equal to P2 V2 over T2. Do you understand? So we will have P1 equal to what? Sorry, P1 is what? 760 times what? Times 790 all over what? 273 is equal to what? 726 times what? 1000, right? Over what? T2. That will give us what? Something times 790. Over over what? 273, right? Is equal to what? 726000, right? Over T2. Are you following? So this will give us all right, T2 equal to what? 726000 divided by what? Okay, times what? 273, right? All over what? 600,400, right? So that will give us T2 will now be equal to 300.109 Kelvin. If we approximate it, yes, we get it. So any question, please? What? Hold on. Okay. All right. Yeah. V1 is what? 800 and what? 50 centimeter cube. C1 is 320 Kelvin. P1 0.92 times 10 to the power 5 what? Newton per meter square. Yes, now. V2, we are looking for V2 now. And what? And P2 is already 760, right? Millimeter mercury. Then T2 is what? T2 is what? 273 Kelvin. No, now they say calculate the volume at STP. Formally, they gave you STP. They say you calculate. Are you getting it? That means the STP is the final. They've given you the initial here. The STP is now the final. In that one, in this one now, STP was initial. And that's if you calculate final. Do you understand? From this, we have to convert this to what? To Newton per meter square. Now, how do we convert to Newton per meter square? Take note that 760 millimeter mercury is equal to 1.01 times 10 raised to the power 5 per, or times 10 raised to the power 5 Newton per meter square. Are you getting it? It's a standard. Okay, it's a standard what? Unit of what? Of measurements. Are you getting it? Right? So already we have this now. There's no need to start converting. So this will be equal to what? 1.01 times 10 raised to the power what? 5 Newton per meter square. Are you getting it? So we use that now. So that will be what? P1 is what? 0.92 times 10 raised to the power 5, right? Yes. Times 850 over what? 320 is equal to what? Is equal to what? 1.01 times 10 raised to the power 5 times what? V2 over what? 273. So if we control and find this, we have V2 is equal to what? 0.92 times 10 raised to the power 5 times 850 times 273 all over what? All over what? 1.01 times 10 raised to the power 5 times 320, right? So 10 raised to the power 5 cancel 10 raised to the power 5, right? So we now have what? Do everything. What will it give you? Check. 0.92 times 850 times 273. What will it give you? What's the answer? 213 points what? Yes. All over 1.01 times 320. What will it give you? 323.2. So what does this one give you? Are you sure? 660 points what? 538 centimeter cube, right? Depends on your answers. The standard approximation is what? Is 2 decimal place. Okay? Alright, but your answer can be in 3 decimal places. So, and that is that about that.